I suppose the question is, how is I to the fourth rewritable, given that you know I squared is negative 1? Yeah, I'm going to go with it, what Eduardo says, albeit he said it really softly. He said,
I squared times I squared.
yeah, say it again loudly.
I squared times I squared.
Yeah, this is I squared times another I squared. Your properties of exponents, yeah? 2 plus 2 giving you 4. But each of these brackets, what's I squared, did we agree? Negative 1 times another gives you a
Positive.
Sweet. Positive what? 1. Answer letter what?
C.
C. Delicious. All right. So expect you get a test in a week and a half. Actually, we lucked out. Do you realize this? Have you seen the schedule for the CSC test? The math test is not until the next to the last testing day. So we have many more days than I had anticipated to fill in our passports and get stickers. Yeehaw. It's great. I'm thrilled. We lucked out.
Yeah, but we don't have stickers.
I think it's April 27th when we finally sit to show what we know in Algebra 2.
We're done with that.
All right. So let's reconvene. Yeah, let's go here. You try, as I said moments ago, you try to factor this quadratic the old school way of factor and solve. It doesn't work. There's nothing to FOIL in the real number world. So you pull out the heavy guns, the quadratic formula, and this expression under the radical symbol, this determinant, becomes -4 when it's simplified. You're giving me this look like, wow, that's a nightmare of a formula, and I'll never remember it for the life of me. But to the point of this discussion, you don't have to remember the formula, only recognize that when the negative number results under the radical symbol, that's when we have to reach not for real numbers, but for complex numbers that entail imaginary piece. You simplify this, and it turns out that the two solutions that make this a true equation are -1 plus I and -1 minus I. This is a classic complex number. Each of those solutions is a complex number, and it's got a real part, and it's got an imaginary part. This is generally, we would say A plus BI, where the A is the real number, and B is the coefficient of the I. Okay? So, Freddie, what's another example of a complex number with a real component plus or minus an imaginary component? -2 plus 2I. Sweet. Precious, what's another one? With a real component and an imaginary component joined by addition or subtraction. -3 plus 1I. Great. Anyone want to offer one last one? Daisy, what do you got? -4 minus 2I. Great. If you are going to take two complex numbers and add them, you simply combine the real parts and combine the imaginary parts. It's almost like combining like terms. So, were you to combine 2 minus 2I plus 4 plus 7I, what are the real components add up to? 6. And the imaginary components? 5. Great. You would say this equals 6 plus 5. Does this seem familiar from earlier in the year? Yeah. Whether or not it does, this part isn't too terribly demanding. You agree? Yeah. Okay. If you're going to add and subtract complex numbers, just as we've said, combine the real components, combine the imaginary components. If you're going to multiply complex numbers, what are you going to do? FOIL. You're going to do double distribution, combining like terms at the end. I'm not going to say anything more about that. However, I warn you, when you multiply this term times that term, I'll warn you. Remember this. Go for it. So This is going to enable you, this discussion, 36, 37, 34. Yep. 34, 36, and 37, we've now,
Done.
well, we haven't done, but we've given you adequate background. 34, 36, 37, yep. What do you need? What's that? For what? Logarithms? Table that for the moment. I want you to focus on the complex numbers. You did get the blue complex number worksheet? Great, that's where you should be, 34, 36, 37. Yep. That I like. I'm worried about your signs. Notorious. Yes. Which number? What do we say about calculators on this particular exercise? No need. The numbers are small enough. Which one? Okay. Johnny, what do you ask? Oh, I thought you had a hand. 34? What does the word product imply? 33. I'm not asking you to do 33 yet, we haven't discussed it. Only 34, 36, and 37. If you are beyond those, then you can check the posters. Victor, you doing your job? Okay. Yes. No. And yes. Did you foil? I want to see the foiling. Show your work. Oscar, how you doing? Yeah. Have you moved ahead of me? Okay. Have you finished the worksheet entirely? Okay. Anyone finished the worksheet entirely? Okay, good. Yeah. Yes. I agree, because you know that I squared is re-reportable, so to speak. Yes. Nice. What's that? Yes, definitely. Yes. I don't know that I love you shouting out the answers, but I like it. I like it. How you doing on this, Precious? Which one you on? 36. Combine the real portions. Combine the imaginary portions. Watch your signs. What do you got? What letter? -3 minus -5. What happens to the sign on that -5? Yes, so what's -3 plus 5? Check it. 2. Yep. And then watch the sign on the imaginary portion as well. You done with the whole thing? Let's see. Yeah, I like that one. This one. Yeah, I like it. 3 for 3. 9 minus what? Which is? Careful. This is 9 minus. What did we say? I squared. Good. You good? Dislike it. You should check with Eduardo. Yes. Do your job.
I just ate all 3.
Yes. 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 3 for 3. What do you got? 0 for 3.
What?
Watch your signs. This is -3 minus -5. What happens to the negative 5 when it's minus 7?
Oh, 37.
Yeah, negative 3 plus 5 is not negative 8. Yes, it is. And negative 2I minus another I.
Wait, hold on.
A total of
It's negative.
check it. Here,
Oh, yeah, because I.
what did we agree in the last FOIL is I times I. What's I times I? D. Yes, which we're going to rewrite as a green box. Green box.
What green balls?
Mr. P,
Yes.
kind of, is this right? 'Cause-
Perfect, perfect, perfect.
Okay.
This is equally,
Wait, how do you-
everything's correct.
Okay.
Well done. Yep.
I get it though, like, I guess because.
We're not there yet.
This is-
We're not there yet. We'll be there in a moment.
This one,
Let's see. Yes. Yes. No. Yes, you blew a sign. That would be 9 minus negative 1. Yep.
So this is
That I like. That I like. It's good work thus far. 1 sec. Check with Maddie. She's your guide.
So, we just leave it like that, or we keep going?
That's it. Hold that thought. We're gonna move on in 30 seconds.
Okay.
Yeah. Hang on to anything that's not blue until 10 minutes from now.
Mr. P, I lost you.
You lost your what? Passport? Logarithms. Put that to the side and favor complex numbers for now. We'll get you a sticker. Can we continue?
Yes.
Sweet. A lot of good work I'm seeing. All eyes up to the next 2 pieces and we'll conclude this worksheet. The next ones you're going to get cheap. They're pretty easy. If we have only real numbers, if there's no imaginary component, we can plot that on a number line. Whether it's a whole number or a decimal, you've seen this since you were little kids. But when you start having complex numbers with a real and an imaginary component, suddenly one line, one dimension is not adequate to graph it. You need 2 dimensions. We're going to say the old school thing, that's the real component, and the vertical, what you know is the y-axis, that's going to be where you graph the imaginary component. Looks like this. If you wanted to graph 3 plus 2i, go out to 3 on the real axis, go up to 2i on the imaginary axis, put a point. This would still be 0, 0. This would be 4 plus 0i, if you like, otherwise known as 4. There are 2 problems where you're asked to graph complex numbers. That's 29 and 31. Will you quickly knock those off? Check with the student next to you. Verify that you did it correctly. I suspect you did it correctly. 29, yep. And Terti1, as my dear old mom would say. What's Terti1?
Yeah.
I'm hearing a lot of a chorus of D, comma C. 29D, 30C. You agree?
Yeah.
Yeah.
I see it. Sarah, you agree? Notice I didn't call you Daisy. I'm working on it.
Yeah.
All right, shall we move on as such? OG, shall we move on? Okay. OG. All right, lastly, this is where it gets diciest, but we're all big kids, we can handle it. Just in the same way that you never leave a radical in a denominator, and we do what's called rationalizing the denominator by multiplying by this purple. What does this purple thing ultimately equal? 1, good. Just as, there's nothing technically wrong with this fraction, but for sort of formality's sake, we rewrite it this way. So too, you never leave a complex number in a denominator. You restate it so that there's no more imaginary component in the denominator.